Hello and welcome guys to Get channel. Today we are going to discuss about schedules. What is a schedule and what are types of schedules. I recommend you to watch my previous lecture before watching this lecture because in my previous lecture I have taught you about asset properties of a transaction. That is very important for understanding this concept. Now let us look at this. What is a schedule? The schedule is a sequence of occurring of two or more transactions is called schedule. If two or more transactions occurring at the same time or one after another, that is called a schedule. Let us say you have a bank account, let us say SBI. So many people have the bank account. So each people have a bank account now, that is called a schedule, you can say like that. So multiple people are having bank account. So the SBI bank schedule we can call like that one. Now schedules are divided into two types. One is serial schedule, another is non-serial schedule. Serial schedule. In serial schedule, one transaction will happen after the execution of another transaction successfully. Means it is one after other. Simply remember it like this. It is one after other. While non-serial execution or concurrent schedule, what does that mean? In concurrent schedules, two or more transactions can happen, but interleaved execution will be there. Means it will be like this. First transaction 1, transaction 2, let us take like this. Transaction 1 happens for some time, then transaction 2 will happen, then transaction 2 will shift to transaction 1 and transaction 1 will happen, then again transaction 2 will happen. Like that the execution will be there. This is called interleaving. Means one transaction completely won't occur at the same time, both transactions occurring at interleaved times. So note it down. After that we are going to discuss some important concepts. Now take a look at this concept. This concept is how many serial schedules are possible for a number of transactions. If I take two transactions, then how many serial schedules are possible? Let us say those transactions for T1 and T2. Then T1, T2 is a possibility and T2, T1 is a possibility. Means T1, T2 means T1 happens first. After the execution of T1, T2 will happen. T2, T1 means first T2 will happen. After the execution of T2, T1 will happen. So two possibilities will be there. So two serial schedules will be there. If I take three transactions, then how many possibilities you can generate? You can generate T1, T2, T3. Like this you can generate 6. T1, T2, T3 means first T1 will happen. After that T2 will happen. After that T3 will happen. T1 happens means that is the complete execution of T1, not the interleaved execution. Like that you can get 6 serial schedules. So for n transactions, what can you say? For n transactions, what can you say? How many serial schedules can be possible? N factorial serial schedules can be possible. This is a very important thing, note it down. Take a look at this one. This is the transaction 1. This is another transaction T2. So transaction T1 has these following steps. First it reads P, then P is updated to 100 and then it writes P and so things are there. And T2 also has some steps it are written in it. We are going to use these two transactions to understand what is serial transactions, what is parallel transactions. So first you note it down. You take a look at this one. This is the transaction 1, this is transaction 2. Transaction 1 happens here, then it after that transaction 2 will happen. So this is a serial schedule. In serial schedule, transaction 1 happens, then after that transaction 2 will happen. Even you can try in this way also. First you can place it here and you can place it here. Then transaction 2 will happen first, then transaction 1 will happen. This is T1, T2. This is called T1, T2. T1 happens first, then T2. If you place this here and if you place this here, this will become T2 to T1. This is serial schedules. Now we are discussing about parallel and concurrent schedules. Note it down. Now take a look at this one. This is transaction T1, this is transaction T2. If you look at this schedule, transaction T1 won't occur sequentially and transaction T2 also won't occur sequentially. Transaction T2 occurs up till here and then interleaving execution is there, and then T2 will happen for some time, and then T2 has interleaving execution, then T1 will happen again, then T1 interleaves and then T2 will happen, and so you can observe here. This type of schedules are called congruent schedules. Concurrent schedule. For as transactions, many concurrent schedules can be possible, but n factorial serial schedules can be possible. Note it down. In this we need to discuss why congruent schedules are required. We have serial schedules. One schedule of one transaction happens after the execution of another transaction. But why congruent schedules are required? If transaction T1 happens exactly before transaction T2 or like this one, then why congruent schedules are required? The interleaving, why is the interleaving of the transactions required? So this is the reason. If there is a serial schedules, then it increases the waiting time, because T1 should complete, then after T2 will execute. Here in this case, T2 will complete, then after T1 will execute. But in a congruent schedule, T2 won't wait for that much time. T1 will execute for some time, and then interleaving of T1 happens, then T2 will run for some time, and then interleaving of T2 happens, then again T1 will run, then again T2 will run. So waiting time is drastically reduced in congruent schedules, and it enhances the throughput and it improves the CPU's utilization. In CPU, if T1 is a process, let us say, and T2 is another process, T1 will run for some time, and then what we call as context switching will happen between T1 and T2. So CPU utilization will be increased like that. Note it down, and thank you for watching this lecture. In next lecture, we are going to discuss about what is the need of serializable schedules.